All right, so we are going to look at the following question. The first question we have here is, if two vectors A and B are such that A dot B is equals to 0, then A and B are parallel, A and B are perpendicular to each other, A is much greater than B, and A is much less than B. Now, from what you've learned earlier, we are told that the formula for A dot B is equals to the magnitude of A times the magnitude of B times cos theta. Now, before everything here will be equal to 0, it means that cos theta must be equal to 0. Now, you are going to look at when two vectors are parallel, it means the angle between them, theta, is 180 degree, parallel lines. Now, if two vectors are perpendicular, it means that the angle between the two vectors, theta, is 90 degree. Now you are now going to plot this into the formula. Cos 90 will give us what? Cos 90 will give us 0. Then cos 180 will give us minus 1. So the correct answer is 90 degree. That means as at when both are perpendicular, A dot B will be equals to magnitude of A, magnitude of B, cos 90. Cos 90 will give us 0, and everything here multiplied by 0 will give us what? 0. So the correct answer to this question is B. Let us see the next one. Newton's law of universal gravitation is given by F is equals to Gm1 m2 all over r square, where F is the force of attraction between masses m1 and m2. If the unit of F, now they gave you the unit of F is this, what is the unit of gravitational constant G? Now, what is the formula for gravitational constant or gravitational force? F is equals to G m1 m2 all over r square. Now, if you cross multiply, make G subject to the formula. The reason why we are cross multiplying is to make G subject to the formula. This multiplied by this will give us what? F r square is equals to G m1 m2. Now divide both sides by m1 m2 m1 m2. This cancel this, and your G will be equals to Fr square divided by m1 m2. Now the unit of G we are given as kg meter per second square, which is minus 2, times r is radius, and radius is in meter, so we have meter square, divided by m1 is kg, m2 is also kg, so kg times kg, the units will give us kg times kg. Now this kg can cancel this kg. From what we said we should arrange, we usually said mass, length, and time. That is the order of arrangement. So if this kg comes up, according to what I have explained to you earlier, it becomes what? Kg negative 1. Then you have meter. Now meter squared times meter will give us what? Meter cube, and then per second. So the correct answer is kg per meter cube per second square, which is option C. Is that okay? Option C. Now let's see the next question. Gravitational and electric field are sometimes referred to as conservative force field because work done in this field depends on the position. Work done on conservative field depends on the position and not on the paths you take to get to those to that position. So if you have A and B, the work done from A to B depends on the position of A and the position of B, and not the path you took to get to A and B. Is that okay? That is what this means. Now, we have the next question. A body of mass 10 kg rests on a plane of coefficient of friction, of static friction, is 0.4. Find the maximum value of theta for which the body remains at rest on the plane. Find the maximum value of theta. Now, you were taught that coefficient of friction is equals to tan theta, right? We are taught something like that. The coefficient of static friction is equals to tan theta. So if the coefficient is 0.4, so we are going to have 0.4 is equals to tan theta. Now what will be our theta? Our theta will be the tan inverse of 0.4. Theta is the tan inverse of 0.4. So the correct answer is option B. That is the formula for coefficient of static friction, not the coefficient of friction is tan theta. Some persons may want to go further by saying tan theta is the same thing as what? Sin theta all over what? Cos theta. Because this will give us mg sin theta for inclined plane divided by what? Mg cos theta. That is where this formula came from. Mg cancels mg for both masses. So sin theta all over cos theta. This will give us what? Tan theta. We are going to look at inclined plane more detailed later. All right. Now, next question says, a rock of mass 10,000 kg propelled by a force of 10 raised to the power of 6 Newton acquires a speed of 7,000 meters per second. Determine the power expended. Now, my dear student, what is the formula for power? Power is equals to force times speed, or force times velocity. That is the formula for power. So in this case, our force was given to us as 10 raised to the power of 6 Newton. The speed is 7,000 meters per second. So P will be equals to, when 7 multiply this, it will give us 7 times 10 raised to the power of 9 watts. All right. So the correct answer to this question is option A. It's quite easy, right? 7 times 10 raised to the power of 9 watts. The unit of measuring power is in watts. Now, the next. Now, it said a boy of mass 10 kg in a lift. If the lift accelerates upward. Now, if the lift accelerates upward with an acceleration of 3 meters per second square, calculate the boy's apparent weight. Now, apparent weight, when the lift goes upward, we are taught that the apparent weight will be m bracket a plus g. That is when the boy, or when the lift moves upward. If it moves downward, it will be equals to what? G minus a. So in this case, our apparent weight, AW, will be the mass is 10 kg, A is 3 meters per second, and then G per second square, G is 10 meters per second square. So our apparent weight would be 10 bracket 3 plus 10 will give us 13. So our apparent weight would be equals to 10 times 13 will give us 130 Newton. That's our apparent weight for this motion. All right, let's see the next question. It's a very simple question. Now, if the boy is coming downward, the apparent weight will be G minus what? A, which is the acceleration with which it is coming downward. All right. Now, the next, a jet airplane engine develop a thrust. A thrust is a forward force on the plane of 15,000 Newton. So FF, I would say the forward force is 15,000 Newton. When the plane is flying at the speed is 300 meters per second. What horsepower does the engine develop? What horsepower? Now, first of all, we need to calculate power. What is the formula for power? Force times velocity, which is also speed. So in this case, the force is 15,000. Velocity is 300. Now when you calculate this, 15,000 times 300 will give us 45,000,000 watts. Now, but this is not the end. So the power in watts is 45,000,000 watts. You must convert this watts to horsepower. So you must ask yourself, how many watts make 1 horsepower? How many watts, or how many watts is 1 horsepower? It's about 746. So we can say 1 horsepower is 746 watts. Is that okay? Therefore, 4,500,000 watts will be equals to X. When you cross multiply, this is going to give us 746 times X is 4,500,000 watts. So divide both sides by 4,000, 7,046. 746 rather, don't mind me. When this cancel, X would be equals to, so simplify this and tell me what you are going to have. So have 450 divided by 746, which will give us 6032.17 horsepower. Approximate value 6030. All right, that is option C. Now the next question, I believe we are going to end it here for this lecture. We'll see in the next one.